Operations with functions. This is a relatively easy unit. It is still a useful unit for symbol manipulation, and that's what we're focusing on. Alright, so here we have two functions, f and g, and here it's some kind of algebraic expression, and g could be another algebraic expression. It could be the same algebraic expression, and we're here, and we're not claiming that f and g are unique. It could be the same exact thing. Okay. All right, then we're going, and you're just going to do things with them. So this notation, right? Remember, this is not f times x. This is the name of the function is f. The name of this function is g. And we're saying the variable or the input is x. So here, this is a similar notation. So what we want you to do is take the two functions f and g and add them, and the input is x. So just add the two functions. If it's f minus g, we subtract the two functions. If it's fg like this or f times g like this, it means multiplication. We multiply the two functions. And if we have f over g, we're going to divide the two functions. And the last one is the composition of functions. So here, when we see this, it does look like fog. It is not read as fog. It's read as f of g of x. Basically read like this, f of g of x. This is where we put the second function into the first function. Let's do some examples. So here are two functions, f and g. F of x is x squared plus 3x, and g of x is x plus 5. So f plus g of x. So that means we're just going to add the two functions. So there's f of x, and there's g of x, and we're adding them. And you just get that, right? 3x plus x is the only two things that can really add. The rest just comes for the adding. F minus g of x. All we're going to do is subtract the two functions, right? There's f of x minus g of x. We subtract them. 3x minus x is 2x. Don't forget to distribute the minus on the 5, giving me the minus 5 here. All right, f times g of x. This is multiply. So this is probably the most involved one, where you have to actually FOIL things out. So x squared times x is x cubed. X squared times 5 is 5x squared. 3x times x is 3x squared. 3x times 5 is 15x. And then combine like terms. And that's what we do. All right, moving on. This is division. This one's, you might think it's as difficult as multiplication, but when you just have this, there's not much you can do with it. Right? You can't even add. If you could cancel, you should, but most of the time you won't even be able to cancel anything or reduce anything. All right, here's the composition. There's several examples of composition here. So we're looking at f of g of x. So we're going to substitute g into f. All right, so we're putting g. We're replacing every instance of x with g of x. So here's what we got. So this exponent of 2 is this exponent of 2. This 3 is this 3. Right? Those correspond to each other. And then this x plus 5 is replacing the x. So the x plus 5 is replacing the x. It's replacing the x. Right? So x plus 5 here is replacing the x here. It's replacing. Right? And then you should work it out. So this x squared plus 10x plus 25 is the x plus 5 squared. FOILed out, right? We have been doing this most of the quarter now. You should be able to square our binomial. All right, so then the 3x plus 15 is just coming from multiplying this out. All right, and then we combine like terms. 10x plus 3x gives us a 13x. 25 plus 15 gives us the 40. All right, let's go. So, okay, next example, we're going to put f inside of g. So we're going to replace x with this function. So here we got. So this x is pretty simple, and we're only replacing it with x squared plus 3x. So this plus 5 is this plus 5. So that's the replacement. We're replacing the x with x plus 3x, which is the other function. And, well, there's nothing much you can do there. All right, now let's do f of f. So here we were substituting f into itself. We're substituting f into itself. Right, so this is f of x. So we're going to replace every instance of x with x squared plus 3x. Right, so this x has been replaced by x squared plus 3x, and this x has been replaced by x squared plus 3x. So this exponent of 2 is right here. This coefficient of 3 is right here. All right, and then you go ahead and multiply this out. X squared plus 3 quantity squared is here. And here we just distribute the 3. And that's what we get. Now we combine like terms. And we get that. So the only 2 terms that combine are these 2. Okay. Alright, so that's the examples for composition of functions. Okay. So what we got? So you should be able to add, subtract, multiply, and divide functions. And you should be able to write the composites of functions. So composition is not quite an operation, but you get the idea. Alright, so that's it. It's a relatively easy section. We're not going to spend a whole lot of time practicing on it. The benefit here is to make sure you know how to multiply, right? The squaring of binomials. Some of us still need practice with those. All right.